Unfortunately, I'm having to do all these videos post, so there's really no good way to start these series. So in no particular order, we're going to start on the flex plate and Bellhousing adapter for the hydraulic pump. I'm going to show you how I came up with the bolt pattern for the Bellhousing adapter and a couple of the parts that I used for the flex plate. Now, if you're unfamiliar, a flex plate is basically just a custom piece built to go between the flywheel and whatever you're attaching up to the motor. So in this case, it's a hydraulic pump. So I'll just kind of show you some of the components here. This is a really nice hydraulic pump that I got off of a silage truck. This is a 40 gallon per minute pump. Works very heavy duty. I was trying to originally put this pump in my truck off the PTO off my 1 ton, but there was no way it was going in there, and the gear ratios weren't right as well. So I found out that this motor that I had the exact same RPM as required for this pump, and it had the same horsepower. Everything was perfect. It lined up perfectly, and I kind of wanted this unit to have its own power pack anyways versus being hooked up to my truck, because I wasn't really going to be able to run the PTO on my truck as I was driving it anyways. So everything just kind of worked out, and this is kind of what I was thinking about building anyways. But I'll show you here on this this Bellhousing adapter. This was all built out of off the rack steel. This is just a, I believe that's a 7-inch by 4-inch piece of 3/8 angle iron, and I hand drilled everything here and hand measured everything. Now, typically the way this would properly be done, or this way this would be done in a professional shop, was that they would send an engineer out, most likely, to come out with some really fancy tools, take some really precise measurements, and he would input all those measurements into a program, and then they would either give you a 2-scale printout that you could come and then tape to whatever pieces of steel that you're working with all the measurements and the center spots marked out on it, and then you just punch through that piece of paper and transfer all those measurements over. Or you could just send that program over to a CNC mill, and then you just put your piece of steel in that mill, and it would edge everything, punch all the holes through everything, 100% accurate. I can't really afford to do all that, and that actually takes a lot longer to do it this way. So this is the quick and dirty way of doing this. And this is by no means perfect, but it's within tolerance, and we'll see how long it lasts. I'm pretty sure there's a few little tricks here that I used for centering and so forth, because I did oversize the hole slightly, so I gave myself a little room to play with. But I'm just going to show you that flex plate. And sometimes these flex plates are actually flexible, and sometimes it's just a name that they use. So that collar on that flex plate is this piece here. It's a 13 spline shaft, 7/8 shaft, and I bought this collar and cut it in half, for one, because it didn't need to be that long, and I'll be able to use this twice now. So I will end up actually building one of these flex plates again in the future for another motor that I'm hopefully be picking up for another project, and then I'll show you exactly the process of building that flex plate, because you might not need a lathe to machine the surfaces true perpendicular to this collar, but it definitely helps. And you want to get as many of these steps as precise as possible, because you don't know if the next step in your process might end up winding up being a little bit out. Let's say you end up stripping out one of these holes in the flywheel, for instance, and having to oversize one of the bolts, and then that's going to throw your balance out a little bit. And then if your flex plate is unbalanced a little bit, and those two areas compound on each other, you're going to start taking out bearings in your equipment. So every step along this process, you want to be as precise as possible. It doesn't necessarily need to be perfect. There's enough play within this shaft, between the shaft and this collar, that if you're just slightly out, it's not going to notice that. Now, a professional shop wouldn't accept that, because if you're talking about a piece of equipment that needs to go out there and operate for 10, 20, 30, 40, 50 years, you want that to be perfect, so that it just gives as much longevity and integrity to that piece of equipment. So you have, you know, because your business name relies on that longevity and quality. That being said, this is just a more or less a prototype of something that I want to try to help me out in my industry of concrete finishing and bricklaying. This isn't going to see that many hours of service. Those little bit of discrepancies aren't going to be that big of a deal. Also, this bell housing, or sorry, this flywheel on this motor is over 2 inches thick, pretty much solid piece of steel. So a little bit of unbalancing within that flex plate is not going to notice it one bit. So again, I'll get into more detail on how I built that flex plate, but the rough, just, you know, just a quick explanation of it was that I put a 3/8 thick piece of steel on a plasma table and cut a circle out, and then cut another circle on the inside that I was able to slip this collar into, and then I weld the collar to it. But you're never going to get that collar 100% true to the face of that plate. So what you do after that is you put this in a lathe, you chuck it up in a lathe, and then this collar will be true to the chuck of the lathe, and then you take a lathe and you face the backside of this plate so that it's once again true. Now, you might end up taking a little bit off one side or the other of that plate as you're truing it, so now the weight's going to be unbalanced, but again, it's not going to notice it in here. Now, what you would do is you would flip that back around and you would machine the other side of the surface, but it wasn't necessary in my situation, because only the face bolting up to the flywheel needed to be true, just to get this perpendicular. I wasn't able to, I didn't have a big enough chuck to chuck the entire plate up so that I could face the front side as well to get the weight properly distributed, but it's not really that much of an issue for me. So that's essentially the flex plate. Once I got that built, then I had to build this Bellhousing adapter, and this was the part that I was worried about, because this is the part that's going to center this pump on that flex plate. And if this is out, you know, for the most part, it's going to center itself. It does have a centering ring, which I unfortunately can't really see, but I had to oversize that centering ring because, again, I didn't have this in CNC equipment. And then I had to oversize these holes as well, just to get everything to fit up nicely. But then what I did was, when I installed this, I just snugged these bolts down. And then I ran the motor for a couple revolutions before this pump was hooked up, and I made sure there was oil in here, but I just ran it for a couple revolutions with the bolts snug but still loose, just to kind of, if it was out of balance at any point, just to kind of center that a little bit. And then I tightened them a little more, ran it again, tightened them a little bit more, and then that should have centered it pretty well. And it feels, there's no chatter, there's no vibration, everything feels like it was pretty accurate. And if it wasn't, it centered itself. So that's how I dealt with that issue. Also, the way I got the bolt pattern to make this plate was by taking a piece of cardboard and clamping it to that bell housing. Sorry about the glare there. And clamping it to that bell housing, clamping it very well so it doesn't move, and then taking a rubber mallet and pounding around the edge. It was this way actually when I was pounding on it, and pounding around that edge to transfer over all my marks. and you could see where the little bolt hole depressions were there. I found the center of those bolt hole depressions, and then I clamped it to this plate and then transferred with a center punch those marks onto my plate. So I think that's pretty much it for the explanation of this. You know, I don't want to get too much into the hydraulic system on this. This still has a long way to go. This is still kind of, some of this stuff is temporary. These hoses, the reason these hoses look so wacky is because these hoses were taken off equipment. They're new hoses, they're unused hoses, but they were taken off equipment that needed heavier duty hoses put on them. So these are single ply. Some of these hoses are single ply. Some of these hoses, they just changed to make them all the same brand as their hose. There's a bunch of different reasons these hoses were taken off, but they're all new. They were previously installed. So that's why the lengths are kind of wacky here. And this also isn't the right hydraulic valve. I need to get the proper spool inside this valve for running motors. So we're not going to get into too much of that, but I just wanted to let you know there is a big hydraulics video coming. I do want to put quick couplers here at some point, because this is essentially going to be a power pack for some other stuff that I'm going to have around the yard, some other attachments, and then potentially a makeshift concrete pump to go alongside this unit, which is going to be a ton of exploratory fabricating in and of itself.